The oil and gas industry is well aware of it, that they have a challenge on their hands, and like in all industries, there's better actors and worse actors. Okay, and I think the better actors are making a real concerted effort to actually address this systematically.
The Rational View is a weekly series hosted by me, Dr. Alan Scott, providing a rational, evidence-based perspective on important societal issues.
Produced by Soapbox Media.
Hello, and welcome to another episode of The Rational View. I'm your host, Dr. Al Scott. In this episode, I'm interviewing a new space entrepreneur who's using optical remote sensing, kind of my field of specialty here, to provide important data on localized greenhouse gas emissions around the world. As you may be aware, the NordStream fossil gas pipelines ruptured a few days ago, and they continue to bubble away unabated. My guest's company has the hardware in place to measure these emissions and determine the potential impacts of this apparent sabotage on the climate. If you like what you're hearing, please press like on your podcast app. Share the episode with your friends on social media, whatever you can. I appreciate hearing from you. Please join our Facebook group, The Rational View. Stéphane Germain is the founder and chief executive officer of GHGsat, whose technology provides actionable greenhouse gas emissions data and insights to various industries. Stéphane founded GHGsat in 2011 to answer a market need for consistent, high-quality measurements of greenhouse gas emissions from industrial facilities worldwide. Mr. Germain has been passionate about applying space technology for the good of the Earth for over 30 years. Stéphane, welcome to The Rational View.
Thanks, Al. Pleasure to be here.
Thank you for coming on. So, could you tell us all a little bit about your background and how you got into the space industry originally?
Well, boy, we might take the whole interview just for that. That's 30 years, right? No, look, this for me is a long-standing passion. I'd always wanted to work as an entrepreneur in the space business, and that intersected with my environmental interests in the sort of 2000s timeframe. As I'm sure you remember as well, that was the time when we were into some really rapid miniaturization of technology. And so I finally managed to kind of find the niche that at the same time addressed environmental issues and enabled me to get into an entrepreneurial opportunity in space when technology got small enough that you could do something useful from a small satellite and do it as an entrepreneur. So that led to GHGsat in 2010, effectively. And then from there, a whole lot of risks, a lot of ups and downs, a lot of craft dinner, and lean times. But it really came together with the launch of our first satellite, first investors, and proving that we could do what we said we could do, because we were quite ambitious at the time and still are, frankly. And from there, when we proved that we actually could do it, it snowballed. From there, it's been a great run. It's been a lot of fun. I'm thrilled to be in a position, 30 years into my career where I can do what I've always dreamed I wanted to do, and it's still just a wild ride and a lot of fun.
I remember back when you started GHGsat, there was great interest amongst the space community to monitor greenhouse gases. I've been in the atmospheric remote sensing for years at that point from space. And, I've been following the National Space Agency's approaches to monitoring Paris Accord compliance by measuring carbon dioxide from space over, countryside scales. But it's a very challenging problem. I mean, NASA and ESA, so ESA is the European Space Agency, were both active in trying to define satellites that could do this. And these are huge monsters because of the sort of, we're looking at parts per million differences in carbon dioxide in a very well-mixed gas to try to detect the country scale differences in that. it just seemed like an intractable problem. And here you are with this tiny little satellite saying that you're going to do this. So what was your inspiration? How did you come up with your ideas?
So you're expressing the skepticism for our ability to do this very well. That's exactly what I was hearing from people in the early 2000s. I'll never forget one of the most respected scientists in Canada looking at me in the eye and saying, "Stéphane, this is hard." I guess I didn't know any better at the time. But no, what inspired us and me and our team to do this is that in 2010, Quebec announced a cap and trade scheme with California. So that's putting a price on each ton of carbon emitted. And that then made the light bulb go off for me, where it had for tens of thousands of people before me, that when you put a price on a ton of carbon, now it's a market price, it should incentivize the people who are responsible for those emissions to want to better control and ultimately reduce those emissions, because it becomes a financial risk. It becomes a financial cost that any company needs to manage and reduce. And so knowing that there was that market incentive, I thought, hey, okay, we really should go, there's a market need that should drive a sensor and or a system. It's not so much a sensor, it's a system that will monitor emissions globally right down to the facility level. And it was clear right from the beginning it had to be down at individual facilities. And that's really what differentiates what we do from those huge missions you're talking about. That all the space agencies are focused and were and are still focused on the big, exquisite satellites that do very high precision measurements of the atmosphere to provide a global record, which is extremely important, and provide a daily monitoring of the entire planet to inform climate change models, which then in turn allow us to figure out, how much warmer is the atmosphere now than it was, at the beginning of the industrial age. And that's where we get this +1, +2 or degrees Celsius above average temperatures. And our satellites can't do that, but that's what these national agency satellites are designed for. So our need was we were answering a very different need. It was individual companies will need to know about their emissions, and so that they can control them and reduce them. And then in working with individual companies, then we're also going to work with governments who are going to want to have the same information, because they're going to want to find the emissions that they otherwise wouldn't have known about. And other parties, like, for example, the financial services market that wants to know, who should I invest in? Who's got the lowest intensity of emissions per unit production, right? So if you've got, how much CO2 are you emitting per unit production? So all of those things were what motivated us. And then, we were looking at what was available in terms of technology, and we just happened to be in, close collaboration with a company that had some really good spectrometer experience. So instrument technology that would allow the detection of trace gases in the atmosphere. And so the main thing that was missing was money. Saw the end market, we thought we had a good technology, and I'll get to a story on that in a minute. And then we just needed somebody who was willing and crazy enough to take a risk with us. So myself and my two co-founders, we put some of our own money, a lot of our own money, into taking this risk. And then Sustainable Development Technology Canada came along and said, we'll take that risk with you as well. And we had to pull some other partners in, but made it all happen. That's how it all started.
Mm-hmm. Now, it's very difficult to find a way to monetize space. And I've spent a lot of time thinking about this problem as well. And very few people have been successful in getting to that point that you're at. There's big costs and big risks and not many good business models. So kudos on you for finding one. That's a huge challenge. Could you describe your business model? Like, how do you make money?
Well, so we go to an individual emitter. So it could be an oil and gas company, could be a coal mining company, could be a landfill operating company, or to a government. And we say, look, we can monitor your emissions from your 10,000 sites all over the world and let you know what your average emissions are, or what your, if there's not supposed to be any emissions, whether we see emissions at all.
Mm-hmm.
And so in some cases, we're helping with inventories, so they can really validate what the top-down measurements we take match their bottom-up estimates. And in other cases, we're just helping them find big leaks fast so they can fix them. And it's a really compelling value proposition for them because they know on the inventory side that the way they estimate their inventories right now is unfortunately sometimes based on 40-year-old emissions factors, like they're literally engineering estimates that really don't make sense with today's technologies and today's environments, but have been, you know how it works, have been enshrined into methods and processes and procedures that this company's done forever and that their regulators require them to do. So the top down is very different from the bottom up, and they can't get caught with the top down showing actually you're emitting twice as much as the bottom up. So they need to be able to reconcile those and understand the difference. So that's on the one hand. On the other hand, the idea of finding big leaks fast is really compelling because there's a kind of an 80-20 situation here where 80% of the total emissions of greenhouse gases, or methane in particular, come from a very small number of sources. And the numbers are not quite 80-20, they're more like 70-10 or so. But so 5 or 10% of the biggest sources are responsible for the vast majority of emissions. So if you can help find those big ones, and it's very much a needle in a haystack kind of problem. If you've got 10,000 wells and or valves and compressors and pipelines all over even just the continental United States or North America, it's a huge challenge to go monitor that stuff all the time and find those big leaks fast. So from the satellite can really do that quickly and in a compelling way. So that's an example of how we can approach any given customer, and then charge for that service, and then we get basically a subscription model for paying for those services.
Wow. Well, that's very cool. I remember looking into this market and talking to people in the government, and they're saying, we don't want to measure from space. We have models now that give us perfectly good numbers. We know exactly how much we're emitting. We don't want your data. Have you encountered that mindset a lot?
So the government is a very different animal, and in fact, we went in this with the mindset that we wouldn't rely on either government funding or on the government being our first customer. We really absolutely wanted to serve end emitters first because they had the immediate problem, and more importantly, they could fix it. But yeah, we've run into that mindset in the government for sure, because they have a very prescribed way that they're told to report emissions. Like if you go to the IPCC guidelines for determining emissions, they have a set rule book by which every country is supposed to estimate what their emissions are, and none of that includes satellite, right? But on the other hand, it's that bottom up versus top down problem I was describing to you. We're finding all kinds of stuff that the estimates aren't getting right. So the people putting together those final estimates of total inventories worldwide are realizing they can't ignore satellites; they have to include it. But on the industrial side, on the emitter side, we also get that attitude, but for different reasons. I mean, sometimes you get people who don't want to acknowledge they've got a leak because as soon as they acknowledge it, they're accepting a liability. And so sometimes we literally get, I don't have a leak, thank you very much, goodbye, click, hang up the phone. It happens.
So you've got this data. It's it's validating the models, and you're finding discrepancies, and it's good. But I mean, so you obviously it would be good to have this as a requirement to validate the markets that people are spending money on, because markets running on models just is rife for problems. You could easily see people gaming the system. But if you've got a monitoring system that can actually measure what's happening, you would think that this should be incorporated in the regulatory framework, should it not?
Absolutely, and I think people are starting to realize that now. So, for example, in Canada's new methane strategy, that very clearly spells out a role for satellites, which it never had before.
Wow.
If you look at the European Union's methane strategy, it includes satellite monitoring. In fact, the European Union, through the European Space Agency's committed billions with a B, of euros for building a new satellite system, another one of these exquisite massive things and this one's called CO2M, which is going to be absolutely amazing and very complementary to what we do, because it's going to keep going with that record of emissions, or not emissions, of concentrations in the atmosphere. But anyway, so satellites are included in the European strategy, and it's even included, believe it or not, now in the U.S. greenhouse gas and methane strategy, especially in the latest Inflation Reduction Act. So there's a lot of traction now for realizing that the models aren't good enough alone, that you do need to have direct measurements, and you need to combine those two sets of data to get to the real picture of what's going on.
Wow. So what's next? Can you tell me a little bit about the technology that you're using? And you're monitoring methane emissions exclusively?
Well, so the instrument we've built is able to monitor specific trace gases. So we basically have to tune it on the ground to look at the gas we want. So when we looked at the market and what people would buy data from us for, the two principal greenhouse gases are carbon dioxide and methane. And most of the carbon dioxide comes from, well-known processes. It's basically combustion. You take a fuel, you burn it, and it creates some sort of energy. And those are usually done in very large stationary sources. Let's set aside cars for a minute. The vast majority of the other emissions are like thermal generating stations, coal plants, aluminum plants, cement plants, that kind of thing. The good news is they really know what those chemical processes are. You take an input fuel, you burn it, and you get an output. So you can estimate pretty well what the total emissions are. So there wasn't a huge demand for that for us. They're starting to be, but we focused on methane because it was the opposite. Methane in nature, like coming from a natural source or even underground when you're drilling, or even from a coal mine, has no smell. It has no color. So you don't know that it's emitting, and yet it's extremely potent as a greenhouse gas, and it has as much impact as carbon dioxide in the next 20 years. When you look at things on a 20-year scale as opposed to 100-year scale, the global warming potential of methane is as important on aggregate as CO2 is. So if when governments and companies are looking for a quick win, they see the opportunity to measure methane and find methane sources as being really important. That's why we targeted methane. So now to get to to answer your question more technically, so the instrument we've developed focuses on methane right now, and it's what's called a wide-angle Fabry-Perot interferometer. It is a patented device. Like we invented this particular permutation of Fabry-Perot. A Fabry-Perot interferometer has been around for 100+ years. It's not a new idea, but to do it in the way we've done it is fairly unique, and it allows for targeting very specific wavelengths, wavelengths corresponding to the presence of a gas we're interested in, and with very high spectral resolution, be able to identify the presence of that gas. And what that all means is we can detect smaller quantities of gas in the atmosphere than any other device that we're aware of today, especially at a high resolution.
Yeah, your targeting of individual emitters allows you to make, I guess, differential measurements rather than absolute measurements.
Correct.
I think that's quite an advantage of this approach, because obviously to get to accurately calibrate it, I know the European Space Agency and NASA are adding additional channels. Like you need the gas monitoring channel, then you need another channel to just measure the local air pressure or the altitude to fractions of a percent to be able to tease out the parts per million changes in the gas they're measuring. So otherwise they're just building an expensive barometer.
Yeah. And you have to do it at different altitudes too, right? So it is a beast of a problem. And they tend to call it as the full physics model, right? Where they're trying to understand what the total profile of the atmosphere is with concentrations of these gases from the ground right up to the satellite. It is really impressive what those scientists can do. We've dramatically simplified it by doing this differential measurement, right? We, over our field of view, which is typically 12 by 12 kilometers, we'll get the background average of the gas. So in our case, the methane that we're interested in, and we're looking for enhancements. So we're looking for increased signal above that background. And that way we don't have to precisely calibrate our atmospheric column, the whole full physics model for the entire column. We can just look at a baseline and look at the differential. Now, it turns out, we've gotten good enough at this now that we probably could do a full physics model as well, but that's not our objective. Our objective really is to look for those enhancements.
Wow. Okay. So that's very cool. And as you say, the methane is, it's basically a source of, it's coming from leaks. It's coming from mistakes. People don't mean to emit methane anywhere. And if you look at the impact on climate, as you say, a lot of people are using natural gas as a backup for renewable energies, for things that are variable and fluctuating, like solar and wind power. And burning this methane, it has lower greenhouse gas emissions per unit energy than, say, coal. So where coal is something like 900 grams of CO2 per kilowatt hour, methane is half that, like 450 grams. But there was a study a few years back looking at leakage from fracking wells and these things, and they said, basically the average leakage of getting methane from the well to the consumer is about 3%. And because of the extremely high greenhouse potential of this stuff, that increases the emission, the equivalent carbon dioxide from 450 grams to about 900 grams. So it's the same as coal with a 3% leakage.
Yep. So that's the magic number. If the whole system can reduce below 3%, then you're better than coal. But obviously the inverse is bad. So yeah, we found that the single biggest source of emissions we see from oil and gas, and we could talk about the other sources as well, but is from what are called unlit flares. So in the world of oil and gas, oil always came first, and the idea was, that's not true in every field now, but originally the idea was to get the oil, and the gas was kind of a useless byproduct. So you wouldn't always capture the gas and send it to market. You'd sometimes just put a big torch on the end of it and burn it, right? So that's flaring. It's when you basically put it out to a big stack and light a match and let the gas flare off. And so, that's obviously wasteful in today's environment because the gas could absolutely be used, but there's a whole bunch of legacy infrastructure out there that has these flares. So it's bad enough when they're flaring, because now when you're burning methane, you create carbon dioxide, and it's actually a very substantial component of all carbon dioxide emissions worldwide. And there's a big effort to reduce flaring worldwide. The World Bank has been pioneering this for many, many years. But it's even worse when the flare blows out. It's like a candle being blown out, right? Sometimes they're supposed to relight. They're supposed to have these thermocouples that detect the fact that that the flame has gone out, kind of like on a furnace at home if you live in northern latitudes like we do in Canada here. When the flame burns out in your furnace, the thermocouple signals that you got to restart it. Well, if your thermocouple breaks, they won't know that their flare is not happening. They'll just be basically pumping methane straight into the atmosphere. And that happens everywhere in the world. And the biggest leaks we see are basically the unlit flares just pumping methane straight in the atmosphere. And it's so easy to fix. So, it's a massive challenge just to work with operators, let them know, first of all, no, trust me, really, you are venting from that particular flare stack. And second of all, here's 10 experts you could work with to bring up best practices for you of how you can monitor this and avoid this happening in the first place. And then there's even, more complicated versions of that when you have incomplete combustion of flares, when you do have a flame, but it's not quite tuned properly, so it gets smoky and you get black carbon, so soot basically coming off the flare. And sometimes you'll have what's called methane slip. So you're instead of being 98% efficient, your flare is now 80% efficient, and that means there's a bunch of methane that's being emitted at the same time as the rest of it's burned. So there's all these complications, but they're huge sources.
Wow. Well, so can you verify the 3% number, or how are people doing? How is the oil and gas industry doing with this? Is it better or worse than 3%, or do you have any idea?
I don't have a measurement against the 3%, but I can tell you anecdotally that there are very significant leaks. It varies by region, right? So the oil and gas industry is well aware of it, that they have a challenge on their hands, and like in all industries, there's better actors and worse actors. Okay, and I think the better actors are making a real concerted effort to actually address this. systematically. It takes time. These are big companies where you even if you have the technology, sometimes the biggest challenge is changing the culture. And so many of them are taking on this challenge and trying to make it happen. But I can tell you that, places like, the place that's craziest in the world right now is in Central Asia. It's a place called Turkmenistan. The oil and gas emissions and the unlit flares in Turkmenistan are just off the charts, and I guarantee you they're well above 3%. But even in other parts of the Middle East, other parts of Central Asia, North Africa, certain parts of the United States, the Permian Basin in Texas and Arizona in particular, are much more prevalent in the emissions of methane than the rest of the country. Certain places in Canada, so there's definitely challenges everywhere in the world, and that's just oil and gas. We haven't talked about coal or landfills yet, which are also very important sources.
Oh, right, yeah. So can you tell us any cool discoveries GHGsat has made that people would not have otherwise thought about? Like, are you detecting things that people wouldn't have thought about?
Yeah, so I'll give you a couple of stories. I mean, on the massive end of the scale, in 2019, there were some scientists who had asked us to go look at mud volcanoes. So mud volcanoes think of like a geyser, like Old Faithful in Yosemite Park. It's something that kind of releases, in that case, sort of versions of steam, but a mud volcano releases methane. And so there's certain places in the world, Central Asia is one, Indonesia is another, where there's active mud volcanoes that just spew methane. So the scientists were telling us, hey, why don't you go look around the Caspian Sea? There's lots of stuff going on there. You can go look in, Kazakhstan, Turkmenistan, Azerbaijan, all those areas have mud volcanoes. So we went and looked, and it was a big yawner. We didn't see anything. But at the edge of our field of view, we spotted this massive emission. And we were like, what the heck is that? So we zoomed in on it, and we realized it was an unlit flare. And so then we said, this thing is so huge that these global satellites that we talked about earlier can probably detect them as well. So we got in touch with the European Space Agency and the science team for a satellite called Sentinel-5P, or also called TRPOMI. And the science team is based in the Netherlands at an institute called ESRON. And we worked with them to compare our measurements with them. And sure enough, we confirmed that both instruments, theirs and ours, were telling us there was something going on, and ours had much higher resolution, so we could actually see what it was. So with that, we tried to get in touch with the operator. This is not an easy place to do business. Turkmenistan is known as a very challenging environment. And so we didn't get anywhere with the operator. So then we approached our Canadian government, and we went to see if the embassy could help us. And they tried, didn't get too far, but then they recruited the European ambassador and the US ambassador. And with the three ambassadors together, they managed to get the attention of the government and had at least this one emission fixed. That one emission was equivalent to taking 1 million cars off the roads, equivalent to 5 megatons of carbon dioxide per year. One emission. And we're tracking about 80 of those right now just in Turkmenistan alone. So, it was a small victory. Unfortunately, a year later, they turned it back on again. But that kind of impact is huge. So that's one story. And that took like diplomatic effort, three ambassadors, but the impact was huge. So now, at the smaller end of the scale, if I just, I'll take a landfill operator in the US, for example. So we work with landfill operators too. They've got methane that come from the garbage that's decomposing in the landfills. And we pointed out to them an area of their landfill that was emitting, that they hadn't realized was emitting. And they realized that they had an issue with one of their pumps that wasn't working because of the fact we'd measured it at the time. So just going to fix that one pump wasn't anywhere near as big as what we detected in Central Asia. But that's an example of a simple, easy, hey, did you know? No, we didn't. Wow, we'll go fix that. And saving, probably in that case, I think it was maybe a kiloton or so. So much, much smaller. But it's still, those kinds of step-by-step impacts are huge over time.
Wow. Yeah, that's amazing. So you're just going out there and trying to save the world here. Do you get paid for doing that?
So it's funny. In one of those two cases, the landfill operator did pay us. The other one has, at this stage, has been, well, actually, it's not true. We're now being paid by third parties to monitor areas of Central Asia because they realize just how important this is. And it's third-party governments, and those governments are now trying to encourage the Turkmenistan government through workshops, through bringing in external experts in oil and gas who can help them, put in place best management practices for their infrastructure. They're trying to slowly cause that cultural change that'll make people realize that this gas is important. We shouldn't just be ignoring it and try to capture it and sell it instead of just letting it vent.
Are you do you have agreements with governments where you have to report these things, or is this just up to your goodwill?
No. So we have agreements now with, well, all kinds of people. So with the emitters directly, with governments, with international organizations. We've sold to NGOs as well, and to financial institutions. So all of the above. So we'll basically sell our data to anybody that needs it for whatever purpose. And in the case of governments, finding stuff they weren't otherwise aware of, yes, we're being asked to track jurisdictions right now in several places in the world, actually.
Wow, that's amazing. Quite good. So I presume GHGsat is doing well as a company now that you have all of this interest generated, and you've got a lot of customers now.
Yeah, we're very healthy. The company's been, has doubled to tripled revenues for the last 3 years straight. We have 6 satellites in orbit now. We're going to double our fleet in the next year. We're launching 6 more next year, and with that, we have even more ambitious plans beyond that. For us, it's clear that the market demand is going to support far more than what we're delivering right now. And that's, some public evidence of that. Just last week, we announced a contract with NASA, for example, where we're part of what they call their commercial small sat data acquisition program. Earlier this year, we announced a contract or an arrangement with the European Space Agency where we're recognized as a third-party mission, which means that we're not one of their missions. We're one of the missions they work with as a third party to provide data to their scientists and to their policymakers that they can't generate themselves. So that's the same thing for NASA and the European Space Agency. So those kind of contracts are making, are helping us grow even faster. And so we're very excited for the future. The business is now over 100 people. And we have, I think, a huge opportunity ahead of us.
And you're headquartered in Montreal, is that it? You talking?
Yeah, so we have offices in Montreal, in Ottawa, in Calgary. In Calgary is where we actually we also operate aircraft sensors. So all our aircraft business is based out of Calgary. And then we have an office in Houston and another one in London in the UK.
Oh, very cool. So one of the reasons that spurred me to invite you on the show was the recent apparent sabotage of the NordStream fossil gas pipelines in Europe. And these events, of course, are extremely important in regards to the geopolitical situation there. These are major methane pipelines from Russia's Arctic fields to Germany that have been in development for quite some time. And Germany, as you may or may not know, has been embarked on this energy wind program to shut down all of its nuclear energy and transition to wind and solar, backed up by fossil gas, mostly from Russia. For the past 15 years, they've been working on doing this. And many critics of the policy, including myself, believe that this kind of put Europe's energy sovereignty in the hands of Putin, basically, and may have set up the conditions that led to the Ukraine war. Be that as it may, these pipelines appear to have been sabotaged by someone like just in the last week. And obviously this promises to further destabilize Central Europe going into a winter when their major gas pipelines disrupted. And these pipelines are bubbling away. I guess there's about a kilometer wide area in the ocean that's bubbling away methane. So have you had a chance to fly your satellite over that and look at that and see what's going on there?
We absolutely have. So as soon as we heard about this in the press, we heard it in the press like anybody else, and we tasked our satellites. So the next day, we tasked our satellites and For the next 2 days, it was cloudy, unfortunately, and our satellites, one limitation is what we do is we have to have a line of sight to the ground, so we couldn't see anything. But on Friday, the 30th of September, we actually had 3 good passes with 3 of our satellites and detected plumes with all 3 of them. So we have we announced one on Friday where we detected one site that was estimated to be emitting 22 tons per hour, and just today, actually, we're releasing the other plumes where one is much bigger. It's about 79 tons per hour. And the other one we actually haven't quantified because we have to be careful with our scientific integrity here. We're not it's not a strong enough signal just because of the particular measurement orientation here, and we can get into what we had to do here to get this measurement over water, but it wasn't a good enough signal in order to give us the quality that we need to be confident in our quantification. So, but we have 3 clear detections, and we quantified 2 of them, and they were all over the same site within a few hours of each other. So it was for us, we hope, a very important contribution to understanding what's going on. As far as we know, that's the only satellite measurement that was done directly of these emissions. And we were able to do it at a very high spatial resolution, so you can very clearly see the origin and the plume shape as well downwind.
So about a total of 100 tons per hour from two of the sources.
No, those are actually from the same source. So in the few hours, there's uncertainties on both those measurements, but so you could, if you wanted to just keep it simple, take an average of the 2 rates, but there's also a time factor here, and we believe it was getting towards the tail end of when these emissions were happening. So it could be that there's an effect of the uncertainties, and there could be an effect in a decreasing amount of emissions over time.
So they are going down. I wasn't aware that they had been petering out.
Oh, they've stopped. Yeah, so apparently at this stage they are no longer visible. So we're still monitoring. We've taken over 25 measurements now with our different satellites, and so we're not seeing anything anymore. But we're going to keep monitoring to make sure that that's true. Or it could be that there's still emissions, but it's below our threshold.
They tailed off then, so they have stopped pumping methane. Okay, that's good. I wasn't seeing anything about that in the media, so this is a revelation to me. Very thank you.
Well, there was we actually got that from media reports. So there were 2 media reports over the weekend that talked about how they were now stopped.
Okay. Very cool. So that's really a useful. So based on your data, can you put this in contrast with other sources? Was this a major environmental catastrophe, or was it just a minor turning off the pipes kind of thing?
No. This is the largest leak we've ever measured. All right, of everything we've done, we've measured hundreds of thousands of measurements of sites around the world. We've got thousands and thousands of active sources we're monitoring around the world. This is the largest one that we've ever measured. So it's a temporary event because we hope it's now stopped, but it was huge. And so this was a very big impact and something we should all be concerned about.
Yeah, I'd heard some calculations. It was like equivalent to the emissions of a small country, basically, in terms of the greenhouse impact.
Yeah, we're all estimating at this point based on the physics of the size and the physics of the pipeline and emission rates through, but we don't really, if you get into the geeky science stuff of it, we don't really know the size of the aperture, and all those things and the amount of gas of each of the pipelines, and so when you put all those together, there's a lot of uncertainty in everybody's estimates, but it was huge. I mean, it's the biggest. In terms of emissions plumes, the biggest we've ever detected, that I can tell you categorically. And when you try to estimate the total emissions, everybody seems to be homing in around 100,000 or 100,000 to 200,000 tons. So it's enormous.
Wow. Okay, that's very cool. So thank you for sharing the scoop with us. So what's next for GHGsat? What's on your radar? Where are you guys going?
So we think we've got a tremendous opportunity to help with the fight against climate change. We'll start there. I think ultimately that's what motivates everybody at our company is that we know that every day what we're doing can make a difference and can really help. We directly work with people who can turn off valves, who can, fix unlit flares, who can, patch a landfill where they know there's something that's leaking. So, I think we have a huge opportunity to make a great impact, and we think we can, by the end of this year, 2022, will have indirectly, working with our partners, mitigated about 10 megatons of carbon dioxide. That's equivalent to,
Wow.
like a small number of thermal power plants, right? And we're just getting started. So that, and I think we can also be a profitable commercial entity in doing that. And the reason that's important is, we're at the end of the day, we're capitalists and we're motivated by, providing a return on investment for our shareholders. But it's also important because we need to be able to sustain ourselves so that we can build more of these satellites and advance the technology. So we have, we're obviously not standing still. Our science team is amongst the best in the world at what they do right now, literally, and they have brilliant ideas for what's next in terms of evolutions of our technology. And so, I don't want to give you the scoop on that just yet, but I think there's some really exciting things to come in our technology, in reducing detection thresholds, providing more coverage, launching more satellites. So, being a healthy, profitable company while at the same time having a huge impact.
Wow. Okay. Well, I'm looking forward to seeing what's coming next out of GHGsat, and I hope things continue. Wishing you all the best in the future, Stéphane. Thank you for coming on the program and for spending your time. I'm going to send you one of these.
All right.
Rational View T-shirt.
Excellent.
You can wear it around GHGsat headquarters.
Thanks, Al. Appreciate it, and I appreciate you giving me the time to talk with you and your listeners.
All right. Thank you so much. If you'd like to follow up with more in-depth discussions, please come find us on Facebook at The Rational View and join our discussion group. If you like what you're hearing, please consider visiting my Patreon page at patron.podbean.com/therationalview. Thanks for listening.